We've got that f of x is a fourth degree polynomial, and we want to first start by finding the zeros of it, given that 1 plus 5i is a zero. So I have some information about a complex zero, and so I need to find the remaining zeros. Well, we're going to perform the synthetic division to do so. And I'll start from the beginning here by multiplying this 1 plus 5i times the 1 that I brought down. This will give me 1 plus 5i. Now I need to combine this here by adding negative 2 plus 1 plus 5i. Negative 2 plus 1 I can add together because they're like terms to get negative 1, but I'll still have the plus 5i. Now, I need to take 1 plus 5i, and now I need to multiply it by the minus 1 plus 5i. So, what I have here is 1 plus 5i times minus 1 plus 5i. When I FOIL this, I get a minus 1. 1 plus 5i is going to give me a positive 5i. But then 5i minus 1 gives me a minus 5i. Those will cancel. And I'm left with plus 25i squared. Well, we know that I squared is negative 1. So this gives me negative 1 minus 25, which is equal to negative 26. So I get a negative 26 here after I FOILed that product. Now, 28 minus 26 is just 2. 2 plus times 1 plus 5i. So I now have to take 2 and multiply it times the 1 plus 5i. So I'm going to get a 2 plus 2 times 5i is 10i. Now I've got a 1 plus 5i that I have to, actually, I did that work already. Now I need to combine these. Negative 4 plus 2 is going to give me a negative 2. So I'll be left with a negative 2 plus 10i. Now I have 1 plus 5i. And this is going to be multiplied to the negative 2 plus 10i. So now I'm here. So I know that when I FOIL, I'll get negative 2. 1 times 10i is just going to give me a 10i. And then I have minus 10i. And then I have 5i plus 10i will give me plus 50i squared. So I have a minus 2. The plus 10i and the minus 10i cancels. I've got a minus 2. And I'm going to add a 50 times negative 1. So that's minus 2 minus 50 gives me negative 52. So my solution here is a negative 52. That's what I got from that product. And we see how this is a 0 because 52 minus 52 is 0. So just as we would expect, and as we were told 1 plus 5i is a 0, and we just showed that it was. Now, here's what we also know. We know that if 1 plus 5i is a 0, so if this is a 0, so is its conjugate. So 1 minus 5i is also a 0. So we know that we've got 1 plus 5i and 1 minus 5i as both zeros. But right now, we see that our solution to this synthetic produced this here. So we'll see here how we can handle this. So I know that the zeros, when we work with complex numbers, come in pairs, conjugate pairs. So what I have is that 1 plus 5i is a 0, implies 1 minus 5i is also a 0. So we have complex conjugates, and these will prove to be zeros. If you have one, you have the other. They come in pairs. So we're going to go ahead, and we've already shown how 1 plus 5i is a 0. I'm going to now work with the 1 minus 5i that I know has to be a 0 because it's the conjugate. And I'm going to perform synthetic division using this 0, 1 minus 5i, along with the solution I just found, where I went from my 4th degree polynomial and I found this 3rd degree polynomial. So I'm here. So I've got 1 minus 5i times 1 is going to give me 1 minus 5i. Now everything here just cancels and we get 0 when we perform the addition and combine like terms. So 1 minus 5i times 0 is just 0. 2 plus 0 is just 2. 1 minus 5i times 2 will give a 2 and a minus 10i. Now this will cancel and we'll get 0, just as we expected, because we knew that the conjugate of 1 plus 5i is also a 0, the 1 minus 5i. So we have that we had the 0 x minus 1 plus 5i. We also know that x plus, or I'll do minus 1 minus 5i, we also know that that's a 0. So what's left is what we just found here, which is x squared. We have 0x plus 2. So in factored form, what we get when we clean this up is that we have an x, we have minus 1. Well, I won't distribute. I'm just going to leave this as factored form. I like it better. But I do want to clean this up, because I have x minus a 1 plus 5i, and x minus a 1 minus 5i. And this can be written as, well, let's see, x squared equals negative 2 means that x equals the square root of negative 2. So x equals plus minus is what I need to include. Can't forget the plus minus. We'll do this. There we go. So now this means that x equals a negative root 2i and a positive root 2i. So I've got x minus root 2i, and I also have x plus root 2i. These are my complex solutions, and this is the factored form that I was desiring. So in factored form, if I were to FOIL all of this back out, I would get back this 4th degree polynomial.